Okay, so now you have learned how to go from the geometric view to the algebraic view. And let's see what's the benefit of learning the algebraic view. And in fact, it's very, very beneficial because doing math within the algebraic view of vectors is very, very convenient. Okay, so we'll end this today's lecture with how do you do math with the algebraic view. Of vectors. So remember, geometrically, when you add them, you do the head to tail thing. Now, let's say I give you two vectors, A, it's 2, 3, B, in the algebraic view, right? So it's 1 minus 1. Okay, if you like, you can sketch this out. It's always good to sketch it out, in fact. Let's make this 1 and 4 like this. Let's make them all positive numbers for now. All right, so how would that look? In fact, before even I added geometrically, in fact, yeah, let's draw that out, right? So A looks like 2, 3, so it looks like this. B is 1, 4, 1, 2, 3, 4, so 1, 4, so it goes like this, right? So that's A, that's B. Well, to add them, you need to put B here, right? So it goes one more unit, and so it goes one more unit this way, and then 1, 2, 3, 4 more units that way. And then this whole thing from here to here, if I can draw a straight line, right? So the blue one altogether is A plus B. Like that. Not too difficult, very easy to do, but it could be easier. I'll show you how to do it in the algebraic view. If you do A plus B, all you have to do, well, let's write that down, right? That's A, that's B. All you have to do is just add them directly across. So the answer, let's even write it in parallel just to emphasize that, is directly 2 plus 1. You can actually directly just add these across. And the answer is 3, 7. There you go, right? Believe it or not, subtraction is exactly the same. You can just directly, if this is a subtraction, you just subtract it, all right? But before we jump ahead of ourselves, let's make sure this is true, not just I say that it is true, right? So let's look at this diagram over here. So look at the blue. The blue, how many, if I can get my blue pen, how many X direction has it gone? Well, first, it went through A, right? It went through 2 units in the X direction. And then when you add B, it went through another one because I'm moving this vector over here. So together, there's 3 units, right? And how about going up? Well, first A, I'm not even looking at the solution over here. That's why I'm hiding it. So for A over here, I'm going up 3 units, right? 4 here. And then for B, I need to, well, I've moved across 1, but then I have to go up 4 units. So together, I have went up 7. So I have 3 and 7, right? So that is correct. In fact, if you think about it in general, if you add any vector, if that's A, and let's say that's B, right? Let's draw that here. That means I go AX unit to the right, AY unit to the top, BX unit to the right, and BY unit to the top. So in summation or in total, right? Of course, you went that amount to the right and that amount, right? This plus this, that amount to the top. So the X component over here would just be the summation of AX plus BX, right? And the Y component over there would just be the summation of AY plus BY. So you can directly just sum them straight across like this, okay? Now, I know you're already thinking ahead of me, right? So subtraction is exactly the same way. So A, if 2, yeah, let's not write that out again. So the rule here is this, right? So then you just write this 1, 4, 2, 3, 1, 4, I subtract it, and it's directly 2 minus 1 and 3 minus 4. So 2 minus 1 is 1, 3 minus 4 is minus 1. Okay. Now I will leave it to you. You should pause this video here. If you're taking notes, I really encourage you to pause your video right over here and try this yourself, right? Draw these two vectors, right? You know what the subtracting b means. It means you take b and you flip it. You flip it negatively, right? So on a grid paper, draw your grids, right? To scale and do this and see if you get 1 minus 1. All right, so do that right now. And when you're back, so pause that right now. Now that you're back, let's talk also about scaling it, right? So just to wrap this up. So what if I want to scale it by 2 times, right? So what is 2a? Again, even without drawing any diagrams, right? So that means 2, right? What's a? A is 2, 3 like this. The rule is this. You can multiply this in like this, okay? And the answer is going to be 4, 6, right? So 2 times 2, let's make that clear, right? So I have 2 times 2 and 2 times 3. So this kind of just goes in, so you have 4, 6. Now I can prove this to you in 2 ways. The first way is just draw out a diagram again, right? So 1, 2, 1, 2, 3, so that's A. And if I need to scale it by 2, so we want to stretch it. So instead of that, so we want to add another 2. Let's do that, right? So add another 2 units and another 3 units up here, right? 1, 2, 3. So how many units going up do we have in total? 1, 2, 3, 4, 5, 6, right? So we have 6 units here. How about to the right? Well, we have 2 here, 2 here, so there's 4. So it's 4, 6. So I can prove it that way, but there's a smarter way to do this, right? Because we know that times is just the same as a plus a added twice, but we already know how to do it algebraically. We don't need to do it geometrically, right? So that is 2, 3 plus 2, 3. Well, of course, that's 4 and 6. So I'll let you convince yourself in general that's true. So here's an exercise for you, right? Now that you understand this. So see if you can do this, right? So if I have, let's say this is V, right? So this is an exercise, is 1, 3, and U is 1, 5, right? So try to do it both algebraically and geometrically. Do V plus U, V minus U, and let's try to scale it by 5 times of V and find out what negative U is, right? So I'll leave this as an exercise for you to give that a try, all right? So I'll summarize the rules here. The rules are, right? So if you have, do it right here, right? So if A is AX, AY, BX, BY, the rule is you can just add them component by component. If you're subtracting, then you have AX, AY, BX, BY. So you have AX minus BX, AY minus BY, like this, right? So I'll put this in a box. Remember that. And lastly over here is if I have some constant, K, times, let's not write that, usually people don't write this, right? Some scalar multiplied by this. So you have this, right? And the rule is the K just goes into both. K times AX, K times AY. Put all this in a box. So now hopefully you see how powerful adding vectors in the algebraic view is, okay? So believe it or not, that's basically wraps up the crucial bits of what we need to know about vectors. And if we have time, we'll also cover one of the question I alluded to. Right now we have arrows, right? We have a very easy way to deal with these arrows, a very algebraic way. Even though this is more visual, this is much quicker in terms of adding and subtracting stuff like vectors. But in the first day, I motivated and asked, how about, well, we've talked about multiplying a scalar with a vector. How about, can I multiply a vector with a vector, all right? So I'll make a separate video about that. And if we have time, we'll cover that as well. But that will not be in the main syllabus, but it's just something interesting to know about as well, okay? After this, we're ready to tackle how do we apply this to physical scenario and how do we apply to understand physics, how to use these arrows. At the moment, it's just playing a game of arrows, but we'll see how this has very good applications in the world of physics to understand how the universe works. Right. See you next time.